Moving virtually to the West Coast, we're here at the Forage, Seed, and Cereal Research Center in Corvallis, Oregon. Not the place you'd expect to see oyster research, but here research geneticist Dr. Neil Thompson works closely with the Oregon State University breeding program to breed new strains of the Pacific oyster. You may not know it, but oysters grown here on the West Coast are much different than the ones we learned about earlier from the East Coast.
One of the biggest challenges that we have on the Pacific coast is how cold our water is compared to the Atlantic. Funnily enough, oysters like warm water for the most part. They grow better in warmer water, and there's just less food on the West Coast compared to the East Coast, and that's just primary productivity being in a colder environment.
With different species and climates comes different challenges for oyster farmers here on the West Coast. The main focus right now is the spread of a disease agent that causes Pacific oyster mortality syndrome.
That has decimated industries in Europe and Oceania down in Australia and New Zealand. This is a viral pathogen, and when it shows up, it can have catastrophic losses to the farm. It's got a really high juvenile mortality rate, and unfortunately, that pathogen has been detected in San Diego Bay in 2018 and then again in 2020.
Researchers believe this complex pathogen attacks the oyster's immune system, leaving it susceptible to bacterial diseases commonly found in the water. Like many shellfish pathogens, there are no pre-tell signs of this disease infecting oysters. All oyster farmers can do is document the mortality rates. The fact that Pacific oyster mortality syndrome has been detected in the San Diego Bay has rung the alarm for oyster farmers up and down the West Coast.
We've got a pretty extensive surveillance network set up to monitor where that pathogen is and isn't along the West Coast, and luckily it has not spread outside of San Diego Bay yet. But one of the biggest concerns I've heard from industry is breeding a more resilient oyster, a more disease-resistant oyster to that pathogen. The West Coast industry is very, very keen on being proactive about this and increasing that disease resistance so that if the pathogen does become more widespread, the losses that they would sustain aren't as catastrophic as what happened in Oceania and in Europe.
Researchers have been placing many different families of oysters in the field and measuring gene performance differences between those families. They then use genetic variation that's naturally present in the oysters and select the best performing ones. This is classical genetic selection, and believe it or not, still involves paper-based records of each family's genealogy.
What we're doing now, and USDA is really excited about, and I'm spearheading on the West Coast, is instead of just using those paper pedigree records, that family history on paper, technology is now advanced to a point where we can actually go in and genotype or sequence many, many genes throughout the genome of each individual animal and get an actual empirical estimate of how related each animal is to each other. We're really excited about the gains that genotyping and that sequencing can give us in terms of improving this disease resistance trait, for example. We'll be able to improve that trait much faster than we would if we were only using the pedigree paper-based selection method.
While Dr. Thompson continues his work on breeding new strains of oysters resistant to Pacific oyster mortality syndrome, he's also studying how climate change is creating new and mysterious issues for the Pacific Ocean.
I often hear from industry partners that there are mortality events that they simply can't explain. That's really challenging and frustrating because it could be a whole host of things. It could be harmful algae. It could be temperature effects. Like on the West Coast this summer, we had a really, really nasty heat wave coincide with a really, really low tide. And so that exposed shellfish for a long time out of water to these really hot air temperatures. In thinking about traits and phenotypes to improve in the breeding program, I'm certainly interested in trying to sort of quantify that environmental resilience to things like temperature, harmful algae concentrations, things along that line that basically stress the animal out where it's growing. Because oysters don't and shellfish don't have the opportunity to swim to a nicer stream or a nicer part of the ocean. Where they are is where they chose to be or where the farmer chose to put them. So that's really the challenge of being an oyster.
Dr. Thompson noted that the biggest environmental change that has impacted oyster aquaculture has been ocean acidification, or the rise in pH levels in the Pacific Ocean. These elevated pH levels have been especially tough on baby oysters.
There were a few years in the late 2000s where there were just mass hatchery mortalities and nobody really understood what was going on. And so that really led into the nascent research around ocean acidification and pH effects.
Trying to solve these mysteries can certainly be challenging, and yes, frustrating for a researcher, but it also gives Dr. Thompson the opportunity to partner with fellow researchers and oyster farmers to find real, tangible solutions to their biggest problems. And it's that type of collaboration that results in a sustainable supply of fresh, healthy oysters that's ready to be placed in your shopping cart. Thanks for listening to this fishy edition of Science in Your Shopping Cart. Stay tuned for future podcasts, and in case you missed it, check out our other podcasts on our website or on our YouTube channel. For Science in Your Shopping Cart, I'm Todd Silver.
Science in Your Shopping Cart is produced by the Office of Communications, Agricultural Research Service, an agency of the U.S. Department of Agriculture. For more information, visit www.ars.usda.gov. Follow us on Twitter, LinkedIn, and Instagram, like us on Facebook, and watch us on YouTube.